Have you ever wondered if you could zip into the future or relive your favorite past moments? Time travel, a concept that tickles our curiosity and captivates our imagination, has been a staple in science fiction literature and film. It's the idea of jumping forward to witness the marvels of the future or stepping back to revisit the echoes of the past. But beyond the realms of fiction, time travel is a complex scientific conundrum, a labyrinth of theories and paradoxes that challenges our understanding of the universe. It's a puzzle that has been tackled by some of the greatest minds in history, each proposing their own interpretation of this enigma. From H.G. Wells' fantastical time machine to the iconic DeLorean of Back to the Future, time travel has been a fascinating idea, igniting our creative fires and pushing the boundaries of what we believe is possible. Time travel, a concept that has sparked our imagination, but is it just a fantasy or does science say otherwise? Enter Albert Einstein, the man who gave us a whole new perspective on time and space. This revolutionary physicist introduced us to the concept of relativity, a theory that has forever changed our understanding of the universe. But what exactly is this theory of relativity? At its core, Einstein's theory of relativity consists of two parts: special relativity and general relativity. Special relativity, proposed in 1905, tells us that the laws of physics are the same for all non-accelerating observers, and that the speed of light is the same no matter the speed at which an observer travels. But it was general relativity, published 10 years later, that truly transformed our understanding of time and space. Einstein proposed that what we perceive as the force of gravity is in fact the curvature of space and time, or what's known as spacetime. Picture it like a trampoline. A bowling ball in the center will cause the trampoline to sag, creating a curve. Now, if you roll a marble along the trampoline, it will move towards the bowling ball not because of a force pulling it, but because of the curve in the trampoline. That's essentially what gravity is. Now, how does this relate to time travel? Well, Einstein's theory also suggests that the presence of mass and energy can warp the fabric of spacetime, causing time to slow down. This phenomenon is known as time dilation. The more massive an object and the closer you are to it, the slower time will run. This means that if you could somehow harness enough energy to significantly warp spacetime, you could theoretically slow down time and even travel into the future. Sounds like science fiction, right? So according to Einstein, time travel might not be a mere flight of fancy, but how does this theory hold up? Time dilation, a mind-boggling consequence of Einstein's theory of relativity, might hold the key to time travel. To understand time dilation, let's imagine a space traveler journeying at near light speed. According to Einstein's theory, time for this traveler would actually slow down compared to someone stationary on Earth. It's as if time has stretched, it's dilated. This isn't a mere science fiction trope, but a reality confirmed by countless experiments. Let's take a closer look at why this happens. It's all about the speed of light, which is constant for all observers, no matter their state of motion. Now, if you're moving rapidly, your speed adds to the light's speed from your perspective. But remember, the speed of light can't change. So something else must. That something is time itself. This is where the concept of time dilation steps in. It's the universe's way of ensuring the speed of light remains constant. For our speedy traveler, time would slow down to compensate for their velocity. The faster they move, the more time slows. So, if they return to Earth after their high-speed adventure, they would find that more time has passed on Earth than for them. They've effectively traveled into the future. But there's another side to this coin. Time also dilates in the presence of massive objects. You see, gravity, the warping of space-time by mass, also affects how we perceive time. Near a massive object like a black hole, time would slow down. So theoretically, if you could survive the immense gravitational pull, you could also time travel into the future by hanging out near a black hole. With time dilation, we can theoretically fast forward, but what about going back? Is that a possibility? The idea of traveling back in time can lead to some perplexing paradoxes. Delving into the realm of time travel, it's impossible to ignore the mind-bending paradoxes it presents. One of the most famous of these is the grandfather paradox. Imagine for a moment that you have the ability to travel back in time. You decide to visit your young grandfather before he has any children. In a shocking twist of events, you accidentally cause his demise. Now here's the conundrum. If your grandfather died before your parent was born, then you wouldn't exist. But if you don't exist, how could you have traveled back in time to trigger your grandfather's untimely end? It's a circular situation with no clear resolution, a classic example of a time travel paradox. This paradox presents a significant challenge to the concept of backward time travel. It seems to suggest that any action which could cause a change in the past, leading to an impossibility in the present, cannot occur. This leads to the concept of a self-consistent universe, where any action taken by a time traveler in the past was always part of history. In this scenario, time travel could exist, but it would be impossible to alter the past in any way that would affect the present. A variant of this is the bootstrap paradox, which involves an item or information that is sent back in time, becoming trapped in an infinite cause and effect loop with no discernible origin. Like a snake eating its own tail, these paradoxes throw our conventional understanding of cause and effect into disarray. The paradoxes of time travel are a fascinating field of study, raising profound questions about the nature of reality, causality, and the fabric of time itself. They challenge our understanding of the universe and remind us of the complexity and mystery of the cosmos. While the possibility of time travel continues to captivate us, it remains a complex enigma, wrapped in scientific theories and paradoxes waiting to be unraveled. Remember, time as we understand it is relative.